So in the previous video, we left it off here. We have our upper terrain. Now in this video, we're going to create caves. There are two ways of doing it. One is with Perlin Noise, second is with Cellular Automata. First, let's start with Perlin Noise. I'm going to open it up, and just down here in the terrain generation, before doing anything, let's just go up here. I'm going to put headers on all of them. So a header called, this is the upper terrain, so terrain gen. So give it a string called terrain gen. All right, I'm going to do that. Then these are the tiles, so let's have a header for that as well. And these are everything else, meaning the other things. We don't have to worry about that. If we do this, what happens is it just creates a header. For example, let me just close this, I guess. Yeah, like this header, which is really good for organizing stuff. All right, now let's have another one and call it cave gen. For our Perlin Noise type of a cave, we just need one value that is called modifier. So a serialized field, float, modifier. And down here in our terrain generation, by the way, instead of doing this, so let me just comment it out. What we will do is we'll have an int called, let's say, cave value is equal to mathf dot round to an integer, because we are going to use Perlin Noise again. It will give us a float value. We have to basically convert it into an integer to put it here. So round to an integer, and inside, let me just semicolon here, and inside we'll do another mathf dot Perlin Noise with x multiplied by modifier, and we'll just put both of them inside a bracket, and then add our seed. Okay, do the same for y, just put y instead of x. And we are done. Now we just have to put our map on that x comma y coordinate equal to our cave value. If you just do this, wait, okay. If you just do this, what will happen is if I go back, hit play, and nothing will happen because there is no modifier here. My bad. So modifier, put it as maybe 0.1. We don't need any value like above 1 or below 0, right? So let's put it inside a range. So just above our modifier, two big bracket and write range, and inside a comma write 0, 1. So after we do that, it'll make a slider here. Just put it at 0.1, which is just enough. Now if I hit play, now you can see the upper terrain is still here, but you can also see these kind of a generation, cave generation, right? These empty spaces could be our cave. Now what I want is I want these chunks to be the cave and these empty places to be the land, right? For that, all we need is just go down here, and instead of doing this, let's have our ternary operator like this, right? Which says map is equal to, put it inside a small bracket, or if our cave is actually equal to 1, right? If that is true, then we'll actually put 0 here, else we will put 1 here. So if our cave gives us 1 as a value, which means land, oh, I have not played it, okay, no problem, which means land, then we'll convert it into 0, which means nothing, or cave. Else, if it gives 0, then we'll put it 1. So that is what we're doing. And now if I hit save and go to Unity, hit play, now you will see these smaller chunks are now the cave system. We can actually just have a border here so that this upper part doesn't become a cave, or maybe this is also good enough. Now, according to our modifier, the smaller the value, the bigger these chunks will be. The bigger the value, the smaller these chunks will be. For example, if I put it as 0.2, it's going to give me this cave generation that looks something like this, which I think you would love it, right? We could have here probably, and we can modify it a little bit more, right? If I put a smaller value, let's say 0.028, it gives big chunk generation. So for me, about 0.2 is actually really good. Now let's create our cave tile. For that, let me just close this. For that, what we need is, first of all, we need in our cave tile system, we need a cave tile. So a tile base, cave tile, and we need a tile map to put that cave tile in. So tile map called cave tile map. Now down here in our terrain generation, what we will do is if our cave value gives us 1, then we will actually not put 0 but put 2. So wherever there is 2, now we'll have a cave generation on that place, meaning in our render. Just first of all, let's have a reference to the ground cave tile map as well as the cave tile. So let's put that here. So a tile map, cave tile map, and a tile base called cave tile. Once we do that, just here make another if statement. So else if our map on a certain x, y coordinate is equal to 2, then let me just copy this. Then we'll actually put our cave tile map, cave tile map. We'll use our cave tile map and put our cave tiles on that. So cave tile. Now hit save. It says something is wrong here because up here we have to change something. So after ground tile map, put a comma here and write cave tile map, and here we also need the cave tile, and we are done. So now if I just go back, okay, nothing is wrong. Now we need a tile base. The tile base is going to be our cave tile, so I'm just going to go to my sprite. This is the cave tile. It's a simple, just gray colored tile, nothing so fancy about that. So let me just go here and put this cave tile on the tile base, which is done. Now for the tile map, I just made a duplicate of this ground tile map and written cave tile map. So let me just put it here. Once you do that, hit play, and as you can see, now we have caves as well, which is awesome. So this is a simple way of making cave generation with Perlin Noise, right? You can add a border. We'll have a system of adding a border, but we'll not do it in this. Maybe we can modify it a little bit more, but Perlin Noise doesn't give actually like a natural looking cave. Like doesn't feel so natural, does it? Let me just hit pause. And by the way, the reason why it didn't update is because we have to clear everything up, right? We're only clearing the ground tile map. We're not clearing the cave tile map at all. So let's make a function which does both. So down here, write void clear map. So basically, let me just cut this ground tile map dot clear all tiles and paste it here. And let's do the same for our cave tile as well. So instead of ground tile map, write cave tile map dot clear all tiles. Once we do that, we can actually call this up here, Control V, and we are done. Now every time I basically generate a terrain, I want it to generate in a random seed, right? So what we can do is write seed is equal to time dot time. Right, so every time I press the generation button, meaning the space key, I will have a random seed according to our time, and I'll first of all clear everything up, then generate an array, meaning put zeros in everywhere in our map, and then put our tile map, which here first of all gives us a Perlin height according to our Perlin noise, and then gives us a cave point, meaning zeros and ones according to our modifier value plus the seed, giving us a constant zeros and ones value. And if it gives us 1 as a value, we'll actually put 2 so that we can have our cave tile. So if we have 2 in our render, right, if we have 2 in our map in a certain position of our height and width, then we'll have our cave tile. Just a basic concept of what's going on here. Now let's hit play. So you have something like this. If I just press the button, and if I just keep on pressing, something like waves happens. Looks kind of cool, doesn't it? I just feel like it's so cool. So, so this is it. The cave generation system with Perlin Noise. Now, after this, we will make caves with Cellular Automita and whichever you like, because this is like the really easy version. All you did was just make a simple one-line code and everything is done, right? It's a really simple version, but Cellular Automata, it's a little bit confusing, maybe even harder, but it makes really good looking and natural looking generations. So we're going to do that next. Alright, for Cellular Cave, first let's just comment this out. And instead of this, let's add something called random fill %. So serialize field, int random fill %. And now down here, let's just comment this out as well. And then up here, we need something called system dot random, and we will call it pseudo random, which will be equal to our new system dot random, and that random will be according to our seed value. So seed dot get hashcode. So this gives random values but according to our seed, so that's why it's a pseudo random. Now we'll have a ternary operator just like this, but it will say something like this. So map x comma y is equal to, and it's an if statement but with a ternary operator. So if our pseudorandom dot next, and it'll give us a random value starting from 1 and to 100, but according to our seed, right? And if that random value according to our seed is actually less than our random fill percent, if that is true, then we'll have a ground tile. Otherwise, we'll have a cave tile. And after just doing that, hit save, go back to Unity. And now, this random fill percent, we only need from 0 to 100, right? So let's have a slider here. So go up here, and here we can just put a range between 0 to 100. Hit save, go to Unity. Now we have a slider. If I do this, nothing will be there, I think, or all of them will be a cave tile, which is awesome. By the way, I'm just going to put it as 100 by 100. 70. All right, but if I put it at about, I don't know, let me just show you again. So if I put it as 0, it will only give us cave tile. Now the more bigger the value, the more tiles there will be. Got it? And a sweet spot is about 55. So if I have 55, it'll give us, you know, a really good amount of land as well as cave, but according to our seed. So if I do this, meaning let's just not have it create new seed, all right? And we'll create the same seed every time. So we have a seed of 420, let's call it that. So if I hit play, see, it will create the same kind of a generation. By the way, let's put it at 35. So it now creates the same kind of a generation. If I just remember this, all right? If I close it, hit play again, then as you can see, the same kind of randomness. Now if I just change this value, maybe, I don't know, 600, hit play, another type of randomness, but according to our seed. And now, because it is a random value, we need to smooth it out to make it look a little bit more natural. And for that, we will create a function called smooth. So just above our render, have a void smooth map, and inside we will loop through the width and the height. So for loop, basically, let me just copy this. It's the same thing, you know. Copy this, put it in here, done. So we'll loop through the width. Let me just remove this. We'll loop through the width, but we will actually not loop through the height, because our generation is only till our Perlin height. But we will not take this value. We have to take a list of Perlin height value, because in every X position, there is different Perlin height because of our Perlin noise system. So we need to put it inside a list, and then we'll loop through that list in here. So how we will do that is just here, right? Well, we don't need to show it in the inspector, so just integer, or you can write public integer, but integer, which will be a list, meaning an array, called Perlin height list. And that list will be as long as our width. So Perlin height list is equal to new integer array with a width of width, right? With a size of our width. Now, down here, we'll just store it into our Perlin height list. So Perlin height list on that X position will be equal to our Perlin height. Just save it like that, and we are good to go. Now put your Perlin height list on that X position here. Now basically, we'll store different Perlin heights inside our array, and we'll go through all of them like this. That is what we're doing. Instead of writing height, write Perlin height list. Now, first of all, let's create a border around our generation. All right, that is the first thing we will do. Right now, if you see here, yeah, there are holes in our generation. We most likely don't want that. So to solve that, what we can do is just put a border around it. So how we will do that is just write if x is equal to 0 or y is equal to 0, or x is equal to width minus 1, or y is equal to Perlin height x, Perlin height list on the x-axis minus 1. Meaning what we are doing here, by the way, if all of this condition is true, if any one of these condition is true, then our map on that coordinate x comma y will be equal to 1. So basically what's happening here is that, let me have our generation here. So we have generated something, right? So what's going on here is that if in our generation we have a tile in this corner where x will be 0, or maybe we have tile in this corner where y will be 0, or we have a tile on this corner where x will be 100 minus 1, meaning 99, so width minus 1, or we have a tile on these height, which is our Perlin height list, individual Perlin height list minus 1. So that is what we're checking. If we have any of these, then we'll just put a ground tile on that place, giving us a border. So if I just go here, and if I just call this now, let me just call it Control C, and let's go at the top here, and before our render, let's just call it here, like this. So once I call it, what will happen is, let's hit play again, and now we have a border. As you can see, everywhere there is a border, which is awesome. Now let's smooth out this generation. So down here write else, and we'll have an integer called basically surrounding ground count, and which will be equal to 0, as well as, for now just follow along. So we'll have a logic called if surrounding ground count is actually greater than 4, then our map on that x comma y will be equal to 1. Else if surrounding ground count is actually less than 4, close this off with a semicolon, less than 4, then our map on that x and y coordinate value will be 2. Now what's going on here is that according to our this, we will actually decide if it's a ground tile or a cave tile. Got it? This is what's gonna happen. So this is where I learned it from. So we made the first randomness. Now we will use Moore's neighborhood. The Moore neighborhood is used to help smooth out the initial cellular automata generation, meaning we'll smooth out these by using Moore's neighbor rule. The rule goes something like this. So check every direction of the neighbor, meaning let's say we just took one of these land, then we'll check all of the surrounding land, meaning we don't care what this is, but according to these guys, this value will be given, the value will be given. So here is the rule again. So we'll check everything, right, our surrounding, and if the neighbor is an active tile, meaning in our case, if in this guy's neighbor we have a ground tile, then our surrounding ground tile count will be added by 1. If it has a cave tile, we won't do anything. That is the first and second and the third rule. Then we'll have a logic. If surrounding ground tile count is greater than 4, then this middle tile will also be a ground tile. If it is lesser than 4, then it will be a cave tile. If it is just 4, then whatever it is, just keep it however it is. And that we will do until we go through all of the tiles. So that is what we're doing here. But now we need to have a system which will help us find out how many cave tiles, or I mean ground tiles, we have in a surrounding, right? For that, let's have a function called int get surrounding ground count, which will take in our grid x, so grid, so int grid x comma int grid y, which will take in those value. And in here, let's have an integer called ground count, and we will return that integer. So return ground count. Now we need to basically loop through one tile behind our initial tile's position and one tile above our initial tile's position, meaning we have to go something like this. Let's say the tile we are choosing has a coordinate of 1, 1. So if it is 1 on the x-axis, loop will start from -1 and end at 2. If it is 1 on the y-axis, loop will start from 1 and end at 2. So there is a simple for loop we can make to do that. But before, let's just call it up here, get surrounding tile count and x comma y. We'll put our x comma y coordinate. So now have a for loop. Now this will be for our grid x. So our I will be neighbor. So neighbor x is equal to grid x minus 1, because we have to go one step behind, and neighbor x is less or equal to grid x plus 1. And that is the loop. That is the loop we have to go through for the x. Do the same for y. So for y, neighbor y is equal to grid y minus 1, grid y minus 1, and neighbor y is less or equal to grid y plus 1. So we only want to check the surrounding of the tiles that are inside our map. So for that, we have to have an if statement that says if neighbor x is actually greater or equal to 0 and neighbor x is less than our width, as well as neighbor y is greater or equal to 0 and neighbor y is less than our height. So meaning if we are inside our map, then we will check. We will basically exclude our middle tile because we want to check the surrounding, so we don't want to check the middle tile. So we have to exclude it. For that, we just have to write if neighbor x is not equal to grid x or neighbor y is not equal to grid y, meaning we are excluding the middle tile coordinate. Then we'll again check if in our map, in the position of our neighbor x and neighbor y, if in our map in this kind of a position, if we have a ground tile, double equal to by the way, if we have a ground tile, then our ground count will be added by 1. So ground count will be added by 1. So ground count plus plus. And now basically we'll go through, loop through the width and the height of our surrounding, right? We'll loop through the width and the height of our surrounding. Then we will see if that value in our width and the height of our surrounding is inside our map, because if it is not, then it will give us index out of array kind of an error. We don't want that. So if it is inside our map, then okay, let's do another thing. We'll check if it is not the middle tile, so we're excluding the middle tile, and if in any of those surrounding tile from our middle tile we have a ground tile, then we'll add it into our ground tile count, and according to that ground tile count we'll get our surrounding ground tile count, and if surrounding ground tile count is greater than 4, then it will be a ground tile. If it is less than 4, then it will be a cave tile. Hit save, go back to Unity. Let's see if we have to make anything. Nope, we don't have to do anything. Let's hit play, and now you see caves being formed. Now if you want to smooth it out a little bit more, and what we can do is you can do multiple count of smoothing, meaning multiple time you can smooth actually more than once. How we can do that is here we need something called an int smooth amount, and we'll have a for loop that will loop until I is less than smooth amount. So after that, let me just do this, Control X and then Control V to put it inside the smooth amount. We'll say something is wrong here because we need a smooth amount value here. So down here we need something called a serialized field int smooth amount and bring that value here, so smooth amount, and we are good to go. Now what will happen is if this is kept as 0, it will give us that random value that we first got. As you can see, totally random. If I put it as 1 and try to generate, it will give us this. See, it just smoothed out everything according to our how many times we did it. So if I do it one more time, maybe 2 times this time, smooth out a little bit more, maybe 3, a little bit more. See, it just removes some tiles that are not necessary. Maybe 4, I think it will be a little bit more unnecessary. Caves are gone. If I do, I don't know, 5, then it'll be a little bit more. See, a little bit more, not much. And about 7 to 10 is a really good amount. See, it gives us really rounded and really natural looking cave. We can have more bigger cave. If you want more bigger cave, just put a lower value, you'll get bigger caves. If you want smaller caves, put a bigger value. Oh, sometimes it doesn't even give you a cave. Maybe try lowering this, but nothing happens. So a general rule is that keep it at 50. It's a really good amount, and keep this as 10. So you get generations like this. If you don't want it like this, keep it at 35. Really good amount. Now, this looks good in a small scale, but what if we had a huge map? right? So let me just close it, 10, and let's have, I don't know, 500 here, and let's try and hit play. It looks kind of cool. See, now we have our cave generation as well as our land generation. You can also, if you want to, try and add both of our cave generation, meaning the Perlin Noise as well as Cellular Automata. And if you want to, I didn't show you this, I'll give you the link of this blog. Right, this is where I learned mostly everything about cave generation. This is the first one, Perlin Noise. But if you want, there are more things like random walkways that gives you generation that looks something like this, which is cool, right? Random walkways. Maybe you can, who knows, do more cool stuff. And tunneling, it is like that. Wait, there is another one. Okay, yeah, tunneling, some kind of this. Maybe you would like something like this. Then Cellular Automata. There are two ways actually. This was the first way, which is called Moore's Neighbourhood, and at the end gives us a really cool looking kind of a generation. There's another one called Van Neummen's Neighbourhood. It's another popular implementation of Cellular Automata, and the rule is like this, the code is also like this, and it gives you generation that looks something like this, a little bit boxy kind of a generation. Maybe you're making some kind of a, I don't know, Spelunky type of a game, and you want chunks of places where you can put stuff, right? And you want it into a kind of a box kind of a generation. Maybe something like that, you can have that. So I'll give you the link here, and you can watch this and learn more stuff. If you have any problem, let me know in the comment section down below. So with that said, thank you for watching. I hope you liked the video. Smash the like button, hit subscribe, support this channel on Patreon if you like. And with that said, again, have a nice day. Bye bye.